Hello all and welcome to our presentation on airflow sensors. This presentation is conducted and presented by all the five names that you see on the board at the moment. The airflow sensor is meant to measure either the volume or the mass of the air flowing through the channel. It is usually placed in the path of the airstream where the user can monitor the status of the flowing air. There are two main types of airflow sensors, a volume airflow sensor and a mass airflow sensor. The mass airflow sensor measures the mass of the air as it travels through the sensor, whereas the volume airflow sensor measures the influence of moving air on the pinwheel and or detected through the plate. In this presentation, we focus mainly on the mass airflow sensor as they are a major use in the car industry.
The principle of the mass airflow sensor is based on two thermally sensitive wires, one which is cold and the other which is hot. By applying a constant voltage over the wire, electrical resistance increases as the wire's temperature increases as well, which varies the electrical current flowing through the circuit. According to Ohm's law, airflow passes air, the wire cools, increasing its resistance, which in turn allows it to transfer more current through the circuit. Since the supply voltage is a constant, as more current flows, the wire's temperature increases until the resistance reaches equilibrium again. The current increases or decreases proportionally to the mass airflow flowing over the wire. The integrated electronic circuit converts this proportional measurement into a proportional voltage, which is then sent to the ECU for further processing in regards to the air-fuel ratio.
Now here is a quick demo of a hot wire sensor. In this demo, a 12-volt power supply is used to power the hot wire mass airflow sensor, and the 5-volt power supply is used as a signal amplifier, and it's connected to a multimeter to observe the changes in voltage. This specific hot wire sensor voltage will vary from 0 to 5 volts. In idle, it will be around 1 volt, and in wide open throttle, it will have a voltage in between 4 to 5 volts. In this video, air is being blown into the hot wire sensor, and the voltage will increase with respect to the amount of air flowing into the sensor.
Internal combustion vehicles use MAP sensors to measure the amount of air entering the engine through the intake manifold that will be mixed with gas for injection. The vehicle's ECU uses the values given by the MAP to adjust timing based on the percentage of air in the air-to-fuel mixture. I used my Volkswagen Jetta as an example to track the airflow rate over different engine speeds and throttle. The yellow line is the throttle percent, the red line is the engine speed in RPM, the green line is the vehicle speed, and the gray line is the airflow rate in grams per second. As you can see, under normal driving conditions, the airflow rate remains steady, but under heavy acceleration, the airflow rate spikes.
Some more examples of automation and applications would be aerodynamics testing. So you could simulate different conditions when doing aerodynamics testing by automatically adjusting the airflow based on the sensor value for conditions you're simulating for the weather or altitude. Another example would be in the many medical applications. A ventilator system would be able to read the airflow of a patient and adjust the amount of oxygen or air needed to keep them alive if they are having difficulty breathing.
Here are some of the special considerations and limitations of the mass airflow sensor. Over time, the sensor can be contaminated by dust and oil particles. This can cause inaccurate readings to the ECU, providing the wrong air-to-fuel ratio. There are mass airflow sensors cleaners available in the market to dissolve dirt, grease, and flux without damaging the electronics. Additionally, the air filters should be changed or cleaned to ensure smooth operations. Generally, the mass airflow sensor should last around 10 years or around 80,000 kilometers to 150,000 kilometers mechanically and electronically, but it is recommended to clean the mass airflow sensor around every 6 months or every oil change to reduce the chances of failing. A faulty sensor will cause many issues to the vehicle. The vehicle will be difficult to start, difficult to accelerate, it will have unstable idles, and if the air-to-fuel ratio becomes too rich, it can damage your catalytic converter, which will be very expensive to replace compared to the MAF sensor. Failed MAF sensor will be detected by the ECM and will be alerted to the driver via the check engine light, and the mass airflow sensor's trouble code can be diagnosed using an OBD scanner. Not all vehicles will require a mass flow sensor, especially older cars with the carburetor will not have a MAF sensor. Additionally, some cars will use a manifold absolute pressure sensor to calculate the air-to-fuel ratio instead. In modern cars and turbocharged vehicles, most will use a mass airflow sensor in conjunction with a manifold absolute pressure and throttle position sensor to deliver the most accurate readings to provide the perfect air-to-fuel ratio of 14.7. In the future, the mass airflow sensor will no longer be needed in automotive applications due to the electrification of vehicles. Thank you for watching. Are there any questions?